Alright, so this video is going to be a further application of chain rule, but also a very important concept of something known as explicit form versus implicit form of an equation. Now, a lot of times the AP test and the calculus curriculum isn't going to test you on knowing what are these words, explicit and implicit. See my little hands? But you're going to use this information to be able to take derivatives. And basically, what explicit form is, I'll just write x for explicit form, is when a function is solved for what the function is. Okay, what I mean by that is that y equals x squared plus 2. Both variables in the function have their own side of the equation. And I guess what I mean by this is that if you took the derivative of this would just be dy dx. Because it's the function y, which equals x squared plus 2, and so it would be the derivative of y in respect to x, because they each have their own side of the equation. And the implicit rule is when they're a little more mixed up than that. It's not just a function of y, it's a function of kind of y and x, which means it's not solved for y, basically. And an example of this, let me see if I just have one that's already solved out. Nope, I don't think we do. So I'll take one up. This would be like x squared plus y squared equals 4. Not only is this not a function, because this is actually a circle, but it's not solved for y. They're on the same side, and yes, you could solve it for y, but you don't actually have to do that. If you want to take the derivative of this top part, well, then you just do power rule, because you're taking it in respect to x, so therefore you can do all of the rules that I taught you without having to chain rule. But now that I've taught you chain rule, you must know that you can take the derivative of this. I'll write this bigger on the top so I have more space to figure this out. But this goes back to the concept that I said before of the dy dx and what that means. Dy dx is basically saying you're taking the derivative of y in respect to x. But in this equation there is no y function because it's kind of all mixed together, and they're not just, this equation isn't just in respect to x, but also it's also in respect to y. What if I ask you to find dy dx, but it's not solved for y, so how could you do that? Well, I'm going to go ahead and, I guess, try and still do d dx like I normally do. But we're going to do the derivative of both sides of the equation. So, because I'm taking it in respect to x, I can just do normal product rule for the x squared, and it'll just be 2x. Now, for the y squared, we're doing the derivative in respect to x, but there's a y. So what we're going to do is we're going to use the power rule and make this 2y, but you have to use the chain rule, because y itself is a function, and the derivative of y is dy dx. So basically, if you're taking the derivative and it's not in respect to a variable that you have to take or a variable that you have to add to the derivative, then you just take the derivative as you would normally, pretending that this is the variable with respect, and then just multiply it times that variable over what you're taking in respect to. And this equals, because the constant rule for this would just equal 0. And now we got it. So now all you gotta do is solve it for dy dx, that's what you're looking for. So dy dx times 2y equals negative 2x, and dy dx equals negative 2x over 2y, or just negative x over y. And that right there is basically the derivative of a circle.